Welcome back to another Regents Physics topic overview. Today we're going to be going over balanced and unbalanced forces. So let's get right into our facts. So for our facts, as always, they're going to be in the description down below. This one is for the full unit of forces for Regents Physics. So starting off here with what a force is. So a force is a push or pull that is applied by one object on another. That's going to be important when we make our free body diagrams later, and it's an important idea for Newton's third law later on in the unit. So for all forces other than the force of Earth, you must be in contact with the object in order to experience a force. This is true for everything in mechanics. There is one other force that we have in here called the electrostatic force later on in the year, in which you're not in contact, but everything besides the force of Earth at this time in the year is always going to be in contact with the object in order to create this force. This unit is going to be Newton's. We're not going to really deal with this as much today, but you'll see it in some of the diagrams. This is going to be the real important fact that we're going to have today. An object's acceleration is in the direction in which forces are unbalanced. We're going to deal with this a lot. If an object, we're going to talk about acceleration just like we did from motion or kinematics. I'm going to have that fact in here again. It's going to kind of drive us in these examples. Balanced forces mean constant speed in a straight line. That's going to be a really important idea when we get into circular motion. For now, if you see constant speed, it's going to mean balanced forces, or better known as equilibrium. This also includes an object that is at rest. Unbalanced forces mean changing speed, otherwise known as acceleration. We have forces acting in the same direction added together to determine the unbalanced force. Again, not going to be as important for today. And forces acting in opposite directions subtract to determine the unbalanced force. So if they don't subtract to zero, we have an unbalanced force. It's going to be that simple. And when you see Newton's second law questions later on in the unit, net force is the same thing as an unbalanced force. So if we have a net force, we must have an unbalanced force. It's the same exact thing. So let's move into some more of our facts. All right, so we're going to make a free body diagram at one point in these examples. So this means that we're going to make arrows representing each force. So again, it is an object on object, so I have to be in contact with something in order to have a force from that besides the force of Earth. So let's say I'm in contact with the floor is going to push up on me and give me a force from that. Then we have a list of forces indicating the object applying the force and the object experiencing the force. So say it is the force of gravity, quote unquote. It's what is creating that gravity. So it's going to be the Earth on the object itself. Mass and weight, not as important for today, but it's going to be throughout this forces unit. Mass tells how much material is contained in an object. The unit for this is kilograms, not pounds that we use in the US. I know in other countries they use kilograms as weight, but weight is actually the force of the planet on the object, and it's simply just my mass times the gravitational field strength for that planet. So for Earth, that's 10 newtons per kilogram. The Regents reference table also has it as 9.81, but you're allowed to use 10, and 10 just makes your life a lot easier. So let's move into our last page for our facts. All right, so our last page of the facts, we start off here at Newton's second law. Not going to be as important for today, but it's just the amount of the unbalanced force set to mass times acceleration. I have it here on the side. It's on the Regents reference table as well, as acceleration equals net force over mass. Same exact thing as the unbalanced force again. And you can only do this when you have an unbalanced force. Otherwise, you cannot set it equal to ma. Normal force. This is a force that acts perpendicular to the surface. So if you're on an incline, it's going to be perpendicular to that incline. So this is a force of a surface on an object. So say I'm standing on the ground, I call that the normal force. That is the force that pushes up on me. Then here at the bottom, we have acceleration. Acceleration we had in the motion unit, but we just want to see it again because we're going to kind of deal with acceleration and unbalanced forces throughout this unit. Acceleration tells me how much an object's speed changes in 1 second once more. And again here, when an object increases speed, its acceleration is in the direction of motion. And when an object decreases speed or slows down, its acceleration is in the opposite direction of motion. All right, so let's get into our two examples here. All right, so example number one, we're going to consider this box in the diagram that is moving to the right while slowing down. What is the direction of the acceleration? All right, so for these examples, they're going to be in the description down below. They're going to be a Google Docs link to them, as well as the facts for forces and the facts for motion, because I'll be referencing those with acceleration here. All right, so whenever I do any explanation question, I do a play on claim, evidence, reasoning, kind of switching the order around and doing evidence, reasoning, claim. My evidence is always going to be a fact of physics from the fact sheet, so that's why I go over that at the beginning of each video. It's a fact that pertains to the situation. Then my reasoning is just the explanation of that fact, essentially, for the situation, and my claim is the answer. This keeps you from going with the claim first and trying to just kind of make sure that claim is correct, even though it might not be. If you start off with the evidence first, you kind of have a more confident way of going towards it. Because you have a fact of physics, oh, I can go back to that and be like, this is actually the correct answer, instead of going all over the place to try and prove that it's the correct answer. So we start off here with a fact of physics. Since we're talking about acceleration, we can use the fact from our motion fact sheet under acceleration. I'm moving to the right and I'm slowing down. So we can say here that when an object decreases speed, its acceleration is opposite to the direction of motion. So I could have this fact out here. When an object decreases speed, its acceleration is opposite to the direction of motion. So that's going to be my evidence. Then we are going to have my reasoning. So just essentially explain the situation. We can say since the box is moving to the right while decreasing speed. This is an explanation of the situation. Since the box is moving to the right while decreasing speed, we can then make our claim and say that our acceleration, since we're moving to the right, opposite direction of motion, the acceleration should be to the left. So that's going to be our answer there. So the box's acceleration is to the left, and that is going to be our claim, our evidence, reason, and claim. It backs up what we have said earlier. Instead of just saying acceleration is to the left, we have a good plethora of evidence for that. So let's move into part B of this question. All right, so for part B, what is the direction of the unbalanced force? So we determined in part A that my acceleration is to the left, and there is a fact that goes along with acceleration and unbalanced force. That is on the forces fact sheet. Towards the top where it says force, we have that an object's acceleration is in the direction in which forces are unbalanced. So I can use that fact here. I start off with an object's acceleration is in the direction in which forces are unbalanced, and that is going to be my evidence. Then my reason is that we can say since the acceleration is to the left, we already determined that the acceleration is to the left here. Since the acceleration is to the left, that's going to be my reason. We can make our claim that our unbalanced force is going to be directed to the left as well. So the unbalanced force is going to be to the left. And we see that based on our diagram here, that it gives us a bigger number, the 120 newtons, to the left versus the 100 newtons to the right. So whenever we have an unbalanced force, it's always going to be a greater number. So if they're asking you, is this number going to be greater or is this force going to be greater? The unbalanced force is the direction in which the force is always going to be greater. That's why it's unbalanced. That part of the force is not being essentially canceled out. So you have 120 to the left, 100 to the right. If you subtracted those, you'd be left with 20. So that 20 is left over. That's from where you had more force. Hence the unbalanced force. It's not being balanced out. That's basically all you need to know with that. This is a Regents question. It would basically just ask you direction of acceleration or something like that. Explain it. You could explain the unbalanced force, explain the direction of the acceleration. It would probably be a multiple choice question. So let's move into example number 2. All right, so for example number 2, we have consider a situation where a person is moving downwards in an elevator while increasing speed. So let me first off just draw my little person in the elevator here, just so we can visualize what's happening. So obviously they're going to be in contact with the ground, and there's my elevator and it's moving downwards. All right, so to draw my free body diagram, we're going to have either things that are in contact with the person or the force of Earth or the force of the planet on the person. So the one that I'm always going to have is the force of planet on the person of the planet on the person, even if I'm falling in the air and I have nothing in contact with me. So that's always going to be straight down. Last time I checked, if I drop something, it would fall straight downwards. And when we annotate this as Fg, you're going to make it the force of the object on the object. So the object that creates gravity is going to be the Earth. So force of Earth on the person. Oops. All right, then any other force must be in contact, or the object must be in contact with the other object, in this case the person, in order to create that force. So the only thing that I am going to be in contact with is the ground while I'm in the elevator. I'm not up against the walls, it doesn't say that, so I'm going to be standing on the ground. So that force is going to be straight upwards because the ground is going to push up on me. And that is going to be my normal force, because that is going to be perpendicular to the surface. So when I'm in contact with a surface, we call it the normal force because that force is going to be perpendicular to whatever surface that I'm on. And I can simply call that the force of the floor on the person. So again, when you have these forces, they have to be either in contact with the object or it's the force of the planet on the person. And it's always the object that we're looking at. Here it's the person that we're looking at. So we're not looking at like the force of the elevator and say like the elevator wire. We don't care about that. We just care about the person inside the elevator and they're in contact with the ground. So that's going to push up on them and we're on Earth, and that's always going to be a downward force, Fg. So that's going to be my free body diagram and my annotations for it. So let's move into part B. So part B, we have what is the direction of the elevator's acceleration. Again, we're going to be moving downwards while increasing speed. So this is going to come again from our motion facts. So if we look at acceleration in motion, I see here that when an object increases speed, its acceleration is in the direction of motion. So again, we're starting off with our evidence. That can be my evidence for this. That is my fact for this situation because we're moving downwards and increasing speed. So we're going to have acceleration in the direction of motion. That's our fact that explains that. Then our reasoning can be, since we are moving downwards and increasing speed, or while increasing speed, whatever you want to say. So since the elevator is increasing speed and moving downwards, that's going to be our reason. We can then say that the acceleration is in the downward direction. So the elevator's acceleration will be directed downwards, and that is going to be our claim. So you can kind of see where this is going based on the last example, or if you're working on the worksheet, we have evidence, reasoning, claim again. We figured out that the elevator's acceleration is directed downwards because I'm moving downwards while increasing speed. So let's get into our final part of this example. All right, so part C, again, was the direction of the unbalanced force. So very similar to example 1, I have the direction of the acceleration. So since I know this, I can use my fact here that an object's acceleration is in the direction in which forces are unbalanced. That's going to be my evidence for this situation again. My fact of physics. then I can go with my reasoning. So my reasoning can be, since the acceleration is directed downward, we figured that out in part B, because again, we are moving downwards while increasing speed. Acceleration is in the direction of motion. So since the acceleration is directed downward, that's my reasoning. I can then have my claim, which is going to be my answer here, that my unbalanced force is going to be downward. And that is going to be my claim for this situation. So again, all the unbalanced force means is that in that direction, my force is going to be greater. So if I'm looking at my free body diagram real quick, let's just draw it out very crudely. We have Fg downwards and Fn upwards. So if it asked, say, was my normal force greater than or less than my weight here or my Fg, it would be less than. Because if my unbalanced force is downwards, that means that that force has to be greater. That's where the greater force is going to be, or the larger force is going to be. So larger force would be downward. So that means that's Fg. So my Fn would be smaller there in that situation. That's a classic Regents question with elevators, because your apparent weight is your normal force. So they always love to ask that depending on the direction of the acceleration. If it's upwards, normal force is greater. Your apparent weight is greater. If your acceleration is downwards, normal force would be smaller than Fg. It's always the direction of the unbalanced force, the direction of the acceleration. That's where the greater force is going to be. All right, so I hope these examples were helpful, and see you guys in class.